In this video, we are going to continue building our micro RPG, and we're going to use it to learn about a concept called polymorphism. So polymorphism is going to take a little bit of setup for us to understand why it's helpful. So we're going to talk about it a little bit on the whiteboard here, and then we'll dive into code. Before we get into it, let me just review a couple of things from last time. So last time we built an RPG game with this class structure. I've got the UML class diagrams here. These are the same ones as last time. I've just filled out some of the missing information. Like last time we didn't put any of the constructors in our UML when we were diagramming. So this matches the code that we created, which I also have pulled up here. So we made this little micro RPG where when it boots up, a series of gigantic insects are displayed, and they each, attack. The ants charge forward and bite, and the bee flies and stings, and these are all sharing some logic through our enemy class. Back on the whiteboard, I did add one new thing here that I want to mention before we get into polymorphism, is that enemy inherits from system.object. So that may be confusing at first because, hey, we never said enemy inherits from another class here. But everything inherits from system.object. And you can actually see that here. If I go back to my game, and let's grab Fire Auntie here and hit dot to see what IntelliSense is picking up as things that we could invoke. So we can see byte and charge and display info, which we defined, but there's also equals, get hash, get type, and toString. We didn't define any of those. And if I click on this to get the autocomplete to pop up, I can see that this is coming from object. And if I click on that, it'll take me in the documentation, or it'll take me into the source code from C# for the system namespace. Here's the public class object, and here are those methods. So our classes, when we create them, even though we don't say they inherit from this, they do inherit from this. So that should explain why I've added system object here as the parent of enemy. Now we can dig into polymorphism. So what I eventually want us to be able to do is something that looks like this. Our final version of our micro RPG will be a game where we get to enter our name, we get some context, we wake up outside with fields of grass that are towering over us, and then we get a little bit of backstory that a science experiment went screwy and we shrunk ourselves down, and now we have to survive a bunch of insects that are attacking us. And then our insects like Fire Auntie and Hades and Buzzbee, one at a time, encounter us in this RPG style battle mechanic where we take turns. So here maybe I'm gonna choose one to throw a clump of dirt at Fire Auntie. It hits, and we can see Fire Auntie's health go down, and the ant chomps at us but misses. Our health stays the same. Maybe I take a mighty swing, it misses. Take another swing, it hits. And when we defeat one of these insects, we're going to be faced with the next one. So to build that final version, we're going to need some way to have players face these enemies back to back. So that might mean that somewhere in our code, we want to have a list or an array that we put our different ants and bees and whatever other insects into. But immediately we're going to run into a problem. If we create a list of type ant, Well, we can't put B's in there. And if we create a list of type B, we can't put ants in there. So if we want to have a collection of all of these different enemies in our game somewhere so that the user can encounter them, we need something else. And this is where polymorphism enters in. And polymorphism, if you break the root down, we've got poly for many and morph for shape or form. So we're going to basically learn how something can act like many different things in our code. So we're going to turn to the documentation from Microsoft here. And I know that the documentation is not always beginner friendly because it wasn't written for an intro to programming class, but it is really important for us to practice trying to parse out this documentation. So polymorphism, we can see here, Greek root, many-shaped, like we were just talking about, and it has two important aspects. So one is that at runtime, objects of a derived class may be treated as objects of a base class in places such as method parameters, collections, and lists. So what that means is that we can take a child class and treat it as if it's a parent class. And importantly, that could be for an array or a list. So if we take our whiteboard diagram here, rather than create a list of ant or a list of type B, we can actually create a list of type enemy and put ants and bees in there. So even though ant is more specific than bee, we can still put it into a collection of its parent class, which is enemy. So that's the important point number one about polymorphism, is that we can treat child classes as if they were their parent class. The other important point is a little bit harder to understand, but basically says that we can implement what are called virtual methods in the parent class and then have our child classes override them. This mechanism allows us, when we have an ant that we have stored as an enemy, to make sure that the ants method gets invoked. So we'll understand that better when we get into code. I recommend taking a look through the documentation here, parsing their example. So they're showing you a class called shape. This is the parent class that has x, y, width, height, draw method. And then there is a circle which inherits from it and overrides the draw method, a rectangle that overrides the draw method, and a triangle that overrides the draw method. So down in this example here, they create a list of that parent class, throw in a rectangle, triangle, circle, and that is allowed because of this polymorphism. We're able to take these distinct things and put them into a list that is their parent class. And then this second point here is polymorphism in action with the overridden draw method. When we call draw here, it's going to make sure to call the rectangle, the triangle, and then the circle's draw method. So again, hopefully this will be enough of a high-level preview, and then when we get into code, it'll make more sense. So let's do that. Let's make a little to-do list here as we're heading into code. So one, we want to create list enemy. Two, let's have, we'll go through our list and display the info for each enemy. And then three, we will bring in virtual and override. So we will use virtual plus override. All right, so pulling up the code from last time here, that would be this project where we have our enemy B, ant. We've got our game. We also had that item class that we created last time so that we could give an ant an item. Let's head back to our game. And rather than store each enemy as a field like we're doing here, what I want to do is create a private list that is of type enemy. And we'll call this enemies. And make sure that you have brought in system collections generic up here so that you can use list without having to use the fully qualified path. So we've got our list enemies, and I think that since we are breaking from this way of doing it where we're storing each one as a field, I'm going to go ahead and delete all of those, and I'm going to turn these into local variables. So ant, fire, ant, Hades, item, leaf ninja star, and let's make Hades pick up that leaf ninja star, and our bee, buzz bee here. So now we can take all of those and put them into our list. So up here, we create a field for a list, but that is not filled in with a value. This is uninitialized. So what we have to do is actually create a list that we're putting into that field. So we're doing that here. And then we could, one at a time, add our enemies to it. So add fire onto here, or we could use the initializer syntax to just pack all three of these in here at once. And I've noticed that I forgot to convert this to our camel case for local variables. So I'm just going to hit Control R and then R again and rename this to BuzzB, the lowercase b. So now we've got all of this complaining at us that we can't do any of this. These fields no longer exist. Let's blow that away. So we've got step one from our whiteboard done. We created a list of enemies and we packed into it our 2 ants and our 1 bee. So that's polymorphism in action already. And we could go ahead and say polymorphism we're able to store all of these into this list because they all inherit from enemy. They all are enemies. So then we can come down here and let's just loop through them. For each enemy in our enemies list, let's ask that enemy to display itself. So we're just pulling them out one at a time, which means that we should see fire onto Hades, Buzzbee printing out in that order because we're looping through them from the start of the list to the end of the list. Nice. There we go. So with this polymorphism, there are a couple of things that are useful to know about with C#. So we can check our enemy and ask some questions about it. We can ask what type it is. We can ask if it's an enemy. We can ask if it's a bee, if it's an ant. So let's do that here. Let's print out some information. This is to help us learn what's going on here. So we can say instance info. So this is going to be information about the current enemy that we've got. And let's right line. What is this instance? And then I'm going to insert the result of calling getType. And remember, getType is that thing that comes from object. So system.object provides us a way to ask what the runtime type is of this variable. So if I just hit play now, we'll see that each one is able to print out what it is. Even though we have stored it as an enemy, it's an enemy in this variable, its runtime type is different. So we're able to say, like, oh, this is actually an ant. This is not really just a basic old enemy. This one's an ant, and this one's a bee. So let's print out a few more things here. I'm going to copy and paste this as a template. So let's say, is this an object? And we can say enemy is object. The is operator allows us to take something and compare whether it's an instance of something else. So is enemy an object? It should be, because object is in the inheritance tree for enemy. So all of these ultimately inherit from object, so we should see true here. And let's add a few more comparisons. So let's say, is this an enemy? So is our local variable an instance of the enemy class? Is this a bee? Is this an ant? So for each of these, we'll see the type, and then we will see the result of asking if the enemy is an object, is an enemy, is a bee, is an ant. So if we fly up to the top, our ant here is an object, so it inherits from object. Object is somewhere in the inheritance tree. It is an enemy, right, because ant inherits from enemy. It is not a bee, and it is an ant. And we'll see the same thing print out here for our Hades ant. And something slightly different print out for our bee, because our bee is an object, it is an enemy, it is a bee, it is not an ant. So the is operator allows you to check if something inherits from something else over here, or is, technically, if this is a compatible type to the thing that's over on the right-hand side of the equation. And let's pull up the docs here. So I'm going to search for C# is operator. And I'll make sure that this is linked, but this is a useful page because it has a couple of the operators and expressions that you can use when you are dealing with types and trying to check types. So we saw the is operator here, which allowed us to check the runtime type of something. Next, let's look at the as operator. So this allows us to convert an expression from one type to a compatible type. Let's see if we've got a decent beginner-friendly example here. You know what? This, I don't think I want to take time explaining IEnumerable, so let's see this in our own code. So we can write an if statement here to say if our enemy is an ant, we can then, if this is true, run a cast. So we can create a new variable ant and take our enemy and convert it to an ant. So this is basically saying, is enemy compatible with our ant class? Then, okay, let's create a new variable called ant where we cast that enemy to our ant class. So now once we're here, we can do ant.byte or ant.charge, which you can't do out here because enemy, this is an instance of the enemy class. So in terms of what we can run when we have an enemy, it's just display info. There's no bite, there's no charge, there's no fly, there's no sting. So if we want access to those more specific things, we do have to do this casting operation. So if we run it, we should see our ant here chomps, charges forward. This one chomps, charges forward. But since our bee is not an ant, nothing else runs here. So we could also do our check for a bee and convert our enemy to a bee instance. And once we've done that, we have access to fly and sting that we created last time. So chomps, charges, this ant chomps, charges, and then our bee takes to the air and lunges with their sharp stinger. So stepping back, what we did here, polymorphism in action, we took our variables of our different types, our ants and bees, and treated them as if they were enemies here to store them in a list. So we have one collection that has all the bees and ants in our game together. Then we can loop over those enemies, and we can, if we need to, convert them back to their more specific types to be able to run bite and charge for the ant and fly and sting for the bee. So this is fine. This technically works, but we've kind of repeated ourselves a lot here. We've done this weird casting to treat all of these things as enemies, and then we've basically undone it here with a bunch of branching logic. So now we can think about how can we do this better? And this is going to be that third point, using virtual and override. So rather than have all of this logic in our branching logic here, what I would rather have is that our bee class has a public fight method that does the flying and the stinging, and our ant has a public fight method that does the charging and the biting. And eventually those fight methods could be AI driven. So like the ant will sometimes bite and sometimes charge based on a random number, or even more, however complex you want to make it. So what I want to do, let's actually go back to game. Let's comment out this stuff and go back to enemy. So I want to create a public method fight. And when fight is called, the enemy should do its specific fight logic. So if it's an ant, it should charge and bite. If it's a bee, it should fly and sting. If it's a spider, it should, do whatever, crawl and jump. So here, let's just put a placeholder that says right line enemy is fighting. As soon as I do this, I am able, back in my game, to do something like enemy.fight. It's not going to do the biting and charging. It's just going to print out that enemy is fighting for each of our creatures here. And let's add a right line to add some white space. It's a little bit easier to read. There we go. So they all have that generic fight method that is coming from enemy. And we can head into ant and create a public void fight. And let's say this method will print out ant and their name. And let's print this out in the color that the ant was created with, and we'll reset the color. So let's ignore this warning for a second. It's telling us that we're doing something that probably needs to be fixed, but that's part of what we're trying to learn here, is why virtual and override are needed. So we're going to take this, we're going to bring it over to our ant, bring this method in to our to our B here, and we can say B is fighting. So let's collapse some of these methods so it's easier to see. We have our B that has a fight, our ant, collapse some of these methods here, which also has a fight, and our enemy, which has a fight method. Right now, if I run this, it is going to call the enemy fight method. Enemy is fighting, enemy is fighting, enemy is fighting. Not what we wanted. We want this to be able to call the ant fight method, where it says Fire Anti is fighting, and Hades is fighting, and Buzzbee is fighting. And eventually then we can refactor those so that this does the flying and stinging for the bee, and this does the charging and biting for the ants. So if we flip back to our polymorphism docs, this is where that second point comes in. So a base class, in this case enemy, can define and implement virtual methods. So we mark some methods as virtual, and then any derived class, our ant or our bee, can override them and provide their own implementation. So what that ensures is that if we call our fight method and we have done our virtual and override, the appropriate ant or bee fight method will be invoked. So this requires that we come back over to our fight method in enemy. The base class, we need to mark this as virtual so that our child classes can override it. So I can head to ant, and let's just override the ant one, leave the bee one broken, and see that if we run this, now we can see that specific ant logic is running. And our specific ant logic is running here for Hades. It's not running here for Buzzbee. So then we can come back and add our override to the fight method in our B class. And once we've done that, ant logic is running here, and our B logic is running here. So if we look at our game, remember we stored all of these as enemies. So at this point, when we are typing enemy.fight, this is an enemy. But because we have marked the enemy's fight as virtual and the ant and bee methods as override, the common language runtime is able to locate the appropriate fight method. So it knows that even though this is stored as an enemy here, when we call fight, it knows to go and run this overridden logic for fight and not run the enemy's fight method. This can be tricky to wrap your head around, so try doing this on your own with an additional method that you create in enemy and you override it in your ant and bee class. That will help you practice this. What I want to do to kind of wrap this up is let's take this fight logic and make it a little bit more interesting. So maybe what we want to do is have a random number, and when the ant is fighting, 50% of the time it'll charge, 50% of the time it'll bite. So what we can do is get a random number, so we'll need a random number generator. Use that random number generator to give us a random number. let's say it's going to be between 1 and 100. If it's less than 50, they'll charge. If it's greater than 50, greater than or equal to 50, they'll bite. And we're going to want to do something similar in B, where they can fly or sting based on a random number. So we could come in here, create a private rand generator, and instantiate it here in the constructor. And then use it down here, rand generator dot next, to get a number between 1 and 100. That would work fine, but this is another place where we could probably say that in our RPG, every creature is going to need this ability to get a random number. They're all going to have some kind of random logic associated with them. So we could grab this, and I want to put it into our enemy and make it protected. That means that any enemy in our game has this ability to use this random generator. And then we need to make sure that we instantiate it in our constructor, because this just creates a field that can store a random generator, but it is empty. So this will be null until we actually set it to a random an instance of the random generator. So let's save this and head back to, I guess we'll start with our ant here. As soon as we've made that, we should be able to get our random generator and use next to get a number between 1 and 100. And let's call this rand num. If rand num is less than or equal to 50, we will go ahead and charge. Otherwise, we will bite. And you may be wondering, like, oh, why'd you do 1 to 100 instead of just a random number that's either 0 or 1? And the reason why I like this is because this makes it easy for me to think about percentages. So if I wanted to adjust this and say, like, oh, only 25% of the time this enemy charges and the rest of the time it bites, I just change this. So now if this random generator gives me back a number less than or equal to 25, I'm charging. So that's 25% of the time charging, 75% of the time biting. And we can do something similar here in our B. And maybe I want to say that the B is 50-50. So the bee will half the time fly and half the time sting. So now when we run it, we should see, whoop, I'm going to have to fix up some of the color information, is fighting. This ant decided to swiftly charge forward. Oh, perfect. This one decided to, also swiftly charge forward. This one just happened to be carrying a ninja star, and our bee lunged forward with a stinger. So the bee stung. Let's try running that again. There we go. So now the bee got a different random outcome. This bee's flying, and our ant did something different. Chomped down, and this one charged. Let's fix that color. I want to reset color after I print this out so that our sting works as expected and our fly works as expected. And let's do the same thing here. Reset it. And now hopefully our name should be showing up in the right foreground color. Yeah, there we go. So with a little bit of random, we're able to get our ants to have really simple AI logic and our bee to have really simple AI logic. This is going to be the basis of the last part that we build together, or I guess the next part that we build together, where we take this from where we've got it currently. We've got an array, we've learned about polymorphism, and these enemies, we're going through one at a time here and displaying them. instead of displaying them one at a time like we're doing here, we want to turn it into an RPG system where you have to face this ant first, and then when you defeat that ant, you face the next one, and then the next one, and you can have as many things in that list as you want, and then you win when you've survived that whole tournament. So in terms of our story, the players shrunk themselves down. They have to battle their way through these gigantic insects, and if they do, they get back to their, shrink machine or whatever and undo it, and they've won the game. All right, so we have our code in a good place. So in the next video, we will build on this polymorphism and actually build out the RPG mechanic.